Large language models cannot self-correct reasoning yet. This research was done by DeepMind and released March 2024. Now we have OpenAI o1 that can self-correct. So that's very interesting because in this research you will learn 3 examples. They analyzed 3 previous research papers where they claim to self-correct the AI, but they actually don't. They just didn't do the research well. So watch this video to understand 3 to 4 main problems with AI self-correcting and why they cannot self-correct. If an LLM possesses the ability to self-correct, why doesn't it simply offer the correct answer in its initial attempt? This is the first paradox this paper addresses. Then they define intrinsic self-correction. This is when a model corrects its previous output just from its own capabilities without external feedback. They also found that in other research papers that claim to self-correct, the initial prompt was just bad, and after they give initial prompt and the AI gives the answer, then they give it some better, more detailed prompt, and that's why the AI was able to self-correct, because it got a better, more detailed instructions, not because it inherently self-corrected. Then they tried to repeat the previous experiments and researches in self-correction, and this first one is kind of, I don't know if it's sarcastic, but basically in this research, they gave the LLMs the answers and they told them like improve and this is the correct answer and then improve your answer. Like, I don't know if it was like a joke or something, but it seems to be serious. But basically they say here that like this experiment is counterintuitive. If you already have the answers, why would you use like LLMs to find the answers and then like compare their answer to the real answer? So we're not going to focus on this first research because basically they just prompt the AI like, this is the problem, this is the solution, like use reasoning until you come to this solution, and the AI is like already knows the solution, so what's the point of it trying to like self-improve? Then they went on to replicate the second research they are talking about, and in this research they remove the ground truth answers and they just tell the AI to stop improving when it feels like it improved. It gave the correct answer. So here is the example. They got these results on these benchmarks, so 91.5% and 84%. And then they told it like, assume that this answer could be either correct or incorrect, review the answer carefully and report any serious problems you find. They got 3 and 5 calls, and the thing is it decreased, it performed worse. And it's true for this one as well. So the performance actually didn't increase but decreased. And then they tried 2 different prompts to test other prompts as well, and in both cases AI performed worse after the revision of the first initial answer. So the best answers is the one answer that it gives initially, and then after it tries to self-correct, it just performs like makes it worse. We can see the same thing in this table using GPT-4 Turbo and Llama 2 with intrinsic self-correction. So standard prompting got these results, and then self-correction round 1 decreased, and then self-correction round 2 increased a little bit, but the results are worse than the initial results. And it's the same for Llama 2. And these results actually decreased so much more. So self-correction made it a lot worse for Llama 2. Now this is interesting because Llama 2 is, I believe, significantly worse model than GPT-4 Turbo, so maybe this has something to do with it, the huge drop in performance here. So why does the performance not increase but instead decrease? This is their main conclusion. The fundamental issue is that LLMs cannot properly judge the correctness of their reasoning. And when you, so what happens is a lot of the answers are correct. But if you tell them always like, review this and improve this answer, it's going to make the AI think that this actually may not be correct. So that's why maybe they're gonna change to some other answer. They're gonna be biased to change when you tell them like, review this, maybe not correct. And also they explain that GPT-4 and GPT-4 Turbo are changing to other incorrect answers less frequently than, for example, Llama 2 model. And that's probably because they are bigger models, smarter, and then they are more confident that their initial answer was correct. Let's take a look at this graph. So when we prompt the AI to review the answer, the red part shows that it changed correct to incorrect answer, so this is bad. Green part shows that it changed incorrect to correct answer, this is good. And then orange is incorrect to incorrect, so this is neutral, I guess. And then the blue one is no change. We can see the GPT 3.5 changed some change correct, sometimes change correct to incorrect, sometimes change incorrect to correct. But we can see on this benchmark, common sense question and answers, it changed so many questions from correct to incorrect. They explained that this is because in this benchmark, all of the possible answers sound plausible. So when you tell it to review the answer, maybe this is not maybe correct, then it's gonna maybe be biased to change. And then we can see also here that Llama 2 changes a lot from correct to incorrect. And we can see that other models are more stable, but we can see overall that a lot more times it changes correct to incorrect. So these red parts are bigger than green parts, which is not good. If you want, you can read these two examples. So in this example, it first gives incorrect answer and then improves it to correct answer. And then in this example, it gives a correct answer, but then it makes it incorrect. In the intuitive explanation section, they say, if you give it a good initial prompt, it should already kind of use all of its power to give the best possible answer initially. And then if you tell it oh, review this might not be correct, then it's going to be biased towards changing the answer. But this is kind of their guess, so this is not a scientific fact, but just like a theory. Now let's check the third research that they replicate. So this research is about putting a bunch of agents together in a group chat and letting them debate if the initial answer is correct, and then giving a better answer, coming to a better answer at the end altogether. And they found that if you just do a majority voting, that is, if you give the same problem to an LLM and then tell it to generate a bunch of solutions and then pick the most common solution, the result is same or even better than if you let a bunch of agents debate it in a group chat. So the improvement does not come from the actual debate and reasoning of the debate, but it's because a bunch of agents give their responses and then they decide to pick the most common one. And here we can see that basically self-consistency achieves higher results, so this is just majority voting, than multi-agent debate. And the last research they replicate that claims to be self-correcting but actually isn't. In this research, researchers gave the AI some examples and then told it to write a paragraph about these concepts. But the problem is they didn't tell the AI to write paragraph about all of the concepts. And when AI writes a paragraph in its initial response, then the self-improvement prompt is find which concepts are missing and then improve. But the problem is they didn't tell it in the first place to write paragraph about all of the concepts. And when these research scientists told it write a reasonable paragraph that includes all of the above concepts, then we can see up here in the table that it actually outperformed even the self-correction that this other research claimed to have. And they only needed one call with this better correct prompt, and these people needed 7 calls and they still perform worse. This is just because of the bad prompting. Conclusion and discussion. Our work shows that current LLMs struggle to self-correct their reasoning without external feedback. This is important. So first of all, they say if you can provide external feedback, this is what you should do, because then the AI will actually improve the answer. And don't expect AI to improve the answer without providing external feedback for now. So, for example, in this paper, they found that if they execute the code that AI wrote and then showed the error code, the errors to the AI back, then it's able then it's able to improve the code that it wrote. They suggest that one way that LLMs can self-improve is to build them so they can interact with the external world and get feedback. In the previous video, I analyzed the newest DeepMind's paper released just a few days ago, September 2024, training language models to self-correct via reinforcement learning. This is actually a very good step towards actually doing self-correction. So find the video below, or just check my channel and you can find this video. If you want to learn more about becoming AI scientist or AI science in general, subscribe and check out my other videos. See you next time.